Alright then, it's time to do something that I promised I would do, and it's to do a counterexample of Fermat's primes. This is going to be done in a bit of a YouTube gamer way, so let's... In the end of this disproof by counterexample video, it was right about here where I started mentioning about this Fermat's prime. Now the actual subtleties of it weren't really expressed in the video, and what it is here, let's have a look at it. If you have 2 to the power of k and then add 1, and that is a prime, then what you have to have is that k is a power of 2. So that's what that's saying about this equation, 2 to the power of 2 to the power of n plus 1. Okay, so this must be a prime. Great. But the thing that we want to prove is actually, is it a prime for every such value of n? So if we put any value of n here, is this always a prime? And what we'll find out is that no, it is not. Whoa! Okay, well anyway, we're going to do this using a Google Sheet. So what we're going to do first is, we'll just do equals 2 to the power of 2. And then we'll do, what's shaking? That plus 1. That's a Fermat prime right there. Here, we're going to do 2 to the power of 2 to the power of 3. Then we're going to do that plus 1. Oh, but that's not quite right, is it? We have to do 2 to the power of 2 to the power of n. So the first one was 2 to the power of 1, so now it's 2 to... Jesus Christ. 16, okay? So what we have here is 2 to the power of 2 to the power of n, and it's going up from 1, 2, 3, 4, and 5. Now this one at the end here, this is the prime which is said to break. It's when it's 2 to the power of 32 plus 1 that breaks. So the way that we're going to check it is by doing proof by exhaustion, or really it's disproof by counterexample. It's just we're going to try all the different types. So the way to do that is we're going to try and divide it by its prime factors. What are its prime factors? Well, then we'll have to know all the primes up to half of that. Now that is a lot of primes. So to make it even simpler, all we're going to do is divide this by every single number. So, but what we want to do, row. So I'm going to return this row, put minus 1 off of it. I think that's right. Let's just check. Equals row. That's 4. Minus 1 is 3. So this one is, this cell here is dividing it by, let's move that there. It's dividing it by 2. Let's just make it a bit more clear. Bum 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 bum. This is getting really boring. Come on, let's make it more interesting. Right, so we've divided by this number. It looks like it's an integer, but I don't think it's gonna be. So we're gonna lock this in using absolute cell referencing, using dollar signs. Bam. Now I don't think this is, yeah, it's not an integer. It was just rounded up. So we're gonna pop out this a little bit, and what we're gonna do is we're gonna pull this down a bit. Bring. So what we're finding out here is that when we divide our original number, this one, let's oh god, that's awful. When we divide this Come on, nice colour. When we divide this yellowy box by the row number, -1, we're getting decimals. So if it's a decimal, then it's not divisible by that. Obviously, we know what a prime is. So if I was to drag this down, we could inspect each and every time. But the thing is that that's going to be quite difficult because there's a lot of numbers that we're going to have to divide by. So what we're going to do is equals that, but we need to round it down. How do you round down? Right. I'm going to round this number down. Round down. Bam, bam, bam. So no matter what this number is here, if we round it down, what we can then do is we'll do the original minus this one, and that's just the decimal. The good thing about that is that what we're going to do here is count if dig 3 greater than 0. Is that right? That's not right. I just want it to count if it, like to mark it as a 1. Count if greater than 0. Let's change that to equals 0. So what we're actually looking for here is that the difference between these two numbers is exactly 0. When it's exactly 0, it's meant that when we've divided by a number, we've got an integer. That's really good, isn't it? Yeah. So what we're doing over here is we're just making it ping up with a 1 if we've found a factor of it. So if we drag these down now on that little square thing there, it makes it just copy the same equation down. Now the absolute cell referencing means that this little bit up here hasn't changed, but all the other bits are changing. And then the bit here, that's just the row number, that's just to get our number that we're going to divide by. And then this is showing like the remainder almost. So all of these are turning up as not finding a factor. That's what the 0 means. So we're just going to keep repeating this until we find it. Now the problem here is that if we do that, we have to keep going until we get to half of this, which is about that many times. So we have to keep doing this that many times, and that's going to be really difficult. So what I want to do is let's just drag this down as far as we can go. Then we'll see what happens from there, and then we'll do something. So right now we're at 300, 400. This might take a long time, but we're just going to do this and see what happens. Right, sweet. Now, to make our life a bit easier, we're going to do some conditional formatting on here. Format. Okay, this should make it so that it flashes up as green when we found our one that divides. Which will make it easy to spot. Not found it yet. So here we go again. Yeah, spreadsheets. Gotta love me damn spreadsheets. Damn it, I wasn't meant to click off. Whoa, 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 what was that? Did I know I saw that. There we go. Yes! Found it already. What this shows is that 641 is a factor of that ridiculous number that we had at the top here, which shows that this hello? Oh yeah, that was what happened. Which shows that this here, this little equation, ping, does not give a prime for when n is 5. Now I know you'd be thinking, what about that one and that one? Apparently they are primes. I don't really want to check them. Should I check them? I don't know, I could do. Got it all set up right now. So we're just going to check the other ones. So this one is meant to be a prime, so this is going to take an awfully long time. So we need to keep going until this number here gets to about 2. To just skip to the end, like the very last entry on a column, I've just pressed Command and down. That's quite useful, that. And then I'm just copy and pasting all the other crap. So my laptop's about to take off. Battery went flat and laptop crashed, so great. Right. Let's go back to the screen recording. So what I actually got up to was, I kept just copying this down and I got up to the bit where divide by this row number and you get to 1.99, which means we've gone more than halfway, which means that's all we need to go to. Now I've got 32,000 rows here and I'm not going to flick through all of them. Like, I'm pretty sure I'll miss it if I see one. Now I didn't see any green cells, but just to make sure, we're going to do equals sum, and we're going to do that, not that, no, we'll just do that, minus sum of that and that. That was not expected. 1. That insinuates that there is one somewhere. That's doing the wrong row. I've really broken this page now. So I've had to stop. Whoa, 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 whoa. Just updated. Let's get the screen recording back on. So I was about to say that my spreadsheet is broke, so I turned the screen recording off because, like, even though we're only working on spreadsheets, Bicky, it's actually, when you've got that many rows going on at once and you're doing a screen recording, it's quite intense on your laptop. We could have done it in something like C++, but this is easier. You could do this on your phone if you wanted to. All right, here we are. What we've got here is we are dividing this number now. Let's change that to blue. We're dividing this blue number by every row number, and then we're looking at what comes out the other side. So we get this decimal, then we round it down, then we look at the difference, and then we say, is that difference 0? If it's 0, give us a 1. Then in this column, this cell here, this grey one, what I've said is add up all the numbers here and take off these two, which shows that there's no factors, which means that this blue number is actually a prime. We could do the same again for 257. That's not going to take as long at all so I can't be bothered to do it, you can do that. So, Fermat's primes. If n is 5, doesn't work. If n is 4, does work. 3, you can check that, but I'm pretty sure it does work. N is 2, what do you get? 17, that's a prime. N is 1, you get 5, that's a prime. Isn't that interesting? Fermat didn't have access to a spreadsheet. Anyway, so that's an example of disproof by counterexample. Not the greatest video I've ever made, but definitely the video with the most spreadsheet in it. That was my sick rig. And see you all next time.